Example 1. The first step in the manufacturing process of phosphorus is the reaction below. The molecular weight of calcium phosphate is 310.2 gram per mole. The molecular weight of silica dioxide is 60.1 gram per mole. And the molecular weight of tetraphosphorus decaoxide is 283.89 gram per mole. If 20.0 gram of calcium phosphate and 20.0 gram of silica dioxide are reacted, A. How many grams of tetraphosphorus decaoxide can be produced? B. What is the limiting reagent? C. How much left for the non-limiting reagent? When we are given a problem, the first step is to write down the most important information. The most important information includes numbers with units, what we are looking for, and a balanced chemical equation if there is a chemical reaction. Generally, we will write down the numbers with units next to the chemical around the balanced chemical equation, because this will help us to identify what kind of calculations we need in order to answer the questions. From our summary, we can clearly see that this is a typical limiting reactant calculation problem. We are provided the masses of both reactants. We need to calculate the mass of one product. We also need to determine which one is the limiting reactant. And we need to calculate how many grams of the non-limiting reactant left after the reaction. Apparently, we need to answer B before we can answer C. Well, you may wonder, Dr. H, how you can tell a problem is a limiting reactant calculation problem? Well, let me tell you the trick. Whenever you're given the masses or the moles or the other information such as the volumes and the densities, but you can convert the information into the moles or the masses of two or more reactants is pretty much a limiting reactant calculation problem. In a typical limiting reactant calculation problem, you may be asked to calculate the mass or the moles or the other information of one product or more products. You may also be asked to determine which one is the limiting reactant. Or, in some scenario, you may be asked how many grams or moles or the other information of the reactants left after the reaction. They are all limiting reactant calculation problems. Let me summarize. Providing the information of two or more reactants is the key criteria to know a problem is a limiting reactant calculation problem. Let me repeat and emphasize. Whenever you're given the masses or the moles or the other information, as long as you can convert the other information into the masses or the moles of two or more reactants, it is a limiting reactant calculation problem. There are different methods to solve a limiting reactant calculation problem. Here, I'm going to teach you only one method. However, if you want to learn more, please feel free to visit my office. I will be more than happy to teach you the other methods. The method I'm going to teach is based on the following fact. If each reactant can be converted into the same product completely, the limiting reactant always gives you the least moles and the least grams of the product. Let me read the fact again because it is very important for you. If each reactant can be converted into the same product completely, the limiting reactant always gives you the least moles and the least grams of the product. You may wonder, Dr. H, what do you mean converted? When I say converted from the reactant to the product, we need to start from each reactant. Use the stoichiometry calculation to convert to the same product. Each conversion from a reactant to the product is a typical stoichiometry calculation. Whichever gives the least grams or moles of the same product It is the limiting reactant. Let me show you the details of the work for this problem. Let me explain the calculation briefly. This is called a conversion factor. It is the molar mass or the molecular weight of calcium phosphate. We can convert from the grams to the moles of calcium phosphate. The second one is also a conversion factor. This conversion factor is from the balanced chemical equation. We have 2 moles of calcium phosphate, and we have 1 mole of tetraphosphorus decaoxide. Coefficients of the balanced chemical equation represent the moles, not the grams of the chemicals. In the balanced chemical equation, we always omit the word moles. The third conversion factor is the molar mass of tetraphosphorus decaoxide. We can see here gram of calcium phosphate and gram of calcium phosphate can be cancelled because one is on top of the fraction and one is at the bottom of the fraction. Similarly, we can cancel the moles of calcium phosphate and the moles of calcium phosphate. We can also cancel the moles of tetraphosphorus decaoxide as well. What we have left is the gram of tetraphosphorus decaoxide, because we are looking for the grams of tetraphosphorus decaoxide. That's why our calculation stops here. Let me show you one more step to show you the mathematical formula of this calculation. This is the formula you need to punch into your calculator. From your calculator, you will get 9.15. The next step we need to do is we will start from silica dioxide. We will do the same calculation but with different numbers. Let me emphasize one thing. When you do these calculations, I strongly suggest you to write down the chemical formulas as well. Because without the chemical formulas, you may cancel the wrong thing. Because moles of silica dioxide and moles of tetraphosphorus decaoxide, without the chemical formula, they look the same. For if you put down the chemical formulas, it can help you to avoid any potential mistakes. Let me compare these two numbers. This is a smaller number. Therefore, calcium phosphate is the limiting reactant. This will be how many grams we are going to get. There's one more thing I want to remind you. Do not eliminate this part. This is our proof to show this guy is the limiting reactant. It's also the proof. This is how many grams of tetraphosphorus decaoxide we are going to get. Let's look at C. How much left for the non-limiting reagent? From our calculation, we can see that silica dioxide is the non-limiting reactant. We want to calculate how many grams of silica dioxide left after the reaction. To calculate how many grams of silica dioxide is reacted. Two methods to calculate the grams of silica dioxide is reacted. Here we use the product to calculate how many grams of silica dioxide during the reaction. Or we can use the limiting reactant, which is calcium phosphate, to calculate how many grams of silica dioxide is reacted. It's better to use calcium phosphate and to use tetraphosphorus decaoxide to calculate, because this is a calculated number. If this number has a calculated error, your final answer will be wrong. But this number is given. It does not have any error. So I'm going to start from here. Calculate how many grams of silica dioxide is reacted. This is a stoichiometry calculation. Let me show you the work. 2 moles of calcium phosphate react with 6 moles of silica dioxide. If you punch this formula into a calculator, you will get 11.6. Remember, we want to calculate how many grams of silica dioxide left after the reaction. What we calculated is how many grams of silica dioxide is reacted. Therefore, we need to take the difference between 11.6 and 20.0 gram. Now we are done. Can you follow my example to find the answer for each problem here? Do you get the same answers as mine?